In this video, we'll take a look at momentum and collisions with a specific focus on inelastic collisions. So we'll take a look at this example. Block A of mass 20 kilograms travels over a frictionless surface at 8 meters per second when it collides with stationary block B of mass 18 kilograms. The blocks separate after the collision and the coefficient of restitution is 0.5. What is the speed of each block after the collision? So the first thing we'll consider is conservation of momentum. Now before the collision we know the mass of A is 20 kilograms and the velocity of A is 8 meters per second. So we can work out its momentum as 160 kilogram meters per second. For B, the mass is 18 kilograms, the velocity or the speed is 0 meters per second. So that has 0 momentum. Now after the collision, the mass of A is still 20 kilograms, but we don't know its velocity or the momentum. For B, it's still 18 kilograms, but again we don't know its velocity or the momentum. Now using conservation of momentum, we can write this equation and we can substitute in the values. So 160 plus 0 is the momentum before the collision, and then after the collision we can substitute in. So we have 20 VAF for the final velocity of A plus 18 VBF for the final velocity of B. That gives us one equation with two unknowns. So we can't quite solve that yet, we're going to need to know something else. So the coefficient of restitution is given as 0.5 in this question. Now the equation for the coefficient of restitution E equals speed of separation divided by speed of approach. So if we substitute in for E and put in 0.5, we can rearrange and we see that speed of separation will equal 0.5 times the speed of approach. Now back to the information we had before, the speed of approach is the speed of A take away the speed of B initially, and so that's 8 minus 0, so it's 8 meters per second for the speed of approach. The speed of separation is the speed of B after the collision, take away the speed of A after the collision. And now we said on the previous slide that the speed of separation will equal 0.5 times the speed of approach for this particular example, because E was given as 0.5. Now if we substitute in, we have VBF minus VAF for the speed of separation, and we have 0.5 times 8 for the other half of the equation. So the 0.5 is the value of E and the 8 is the speed of approach. So simplifying that, we now know that VBF minus VAF equals 4. And that equation is a second equation that has VBF and VAF. And we now have two equations and two unknowns. So bringing those together, we'll label the first equation 1 and then the second equation 2. And what I'm going to do here is I'm going to multiply equation 1 by 20. So we have 80 equals 4 VBF minus 20 VAF, and I'll call that equation 3. Next, I'm going to add equations 2 and 3 together. So we have 240 equals 38 VBF. And because we had plus 20 VAF in equation 2 and minus 20 VAF in equation 3, they cancel out. Now rearranging this equation, we find that VBF equals 6.32 meters per second. If we rearrange equation 1, we can use that to work out the value of VAF, the final velocity of A, and that comes out to be 2.32 meters per second. So overall, we've solved the problem. We now know the velocity of the two blocks after the collision. So that's been a video about momentum and collisions focused on inelastic collisions. I hope you found that useful. Please remember to like, comment and subscribe, and thanks very much for watching.